This lesson is going to be about three theorems that have to do with proportions in triangles. The first one is called the side splitter theorem, and this one has to deal with when you have a triangle that has a parallel segment drawn to one of the sides of the triangle. So we talked about this before in terms of if you know, I'm just going to put some letters on here to make this easier to kind of see what's happening. So W and V will be the parallel segments, then I've got A, B, C, and D as the segments on the sides. Okay, so we talked about it before in terms of if you used, because that segment's parallel, that makes these angles congruent. So the triangles are similar. The triangles are similar by angle-angle similarity. And so we said W is to C, for example, as V is to C plus D. And we were using the whole triangle sides. Okay, so that's a proportion that's involving the parallel segments. So if you use the parallel segments, then you have to use similar triangles. Okay, so if we do W is to C as V is to this whole side length C plus D, we're using the little triangle similar to the big triangle, or any equivalent proportion. Okay, what's new in this lesson is, and I kind of probably mentioned this before, when you have those parallel segments, as long as these segments are parallel, then it's true that the segments that are formed on the sides are proportional. So A is to B as C is to D. Or any equivalent proportion. So you could say A is to C and kind of go back and forth. So A is to C as B is to D. Now again, we know those are the same proportion because when you cross multiply, you get the same thing. A times D equals B times C. So you can still do similar triangles on the sides as well. So you can still do A is to A plus B as C is to C plus D using the whole side length. So C is to C plus D and A is to A plus B. That still works because, again, you're using similar triangles. But it's a little bit simpler if you know the segment lengths on the sides and that segment is parallel, then you can just use the parts. So A is to B as C is to D. This is super important that you understand the difference between these two, because this is a really common mistake, is people try to do, for this one over here, they try to do W is to C as V is to D, and that doesn't work because W and V, being the parallel segments, have to be proportional using the similar triangles. Okay, so applying that with some problems here, we've got, again, start with the fact that you have parallel segments. So we know these segments are parallel, therefore we can use a side splitter theorem. So I'm going to say 18 is to 6 as x plus 22 is to x plus 2. And the reason I chose to do 18 to 6 is because that's a nice 3-to-1 ratio. 3 is to 1 as x plus 22 is to x plus 2. Resist the urge to try to cancel on the right side of the proportion because that 22 and 2 doesn't cancel since there's plus signs there. So we're ready to cross multiply, and we're going to have 3x plus 6, because I'm distributing, is equal to x plus 22, which makes 2x equal to 16, and x would be 8. Okay, now, you could have done, it would have worked if you had done something like 18 is to x plus 22 as 6 is to x plus 2. So if you go 18 to x plus 2 and then 6 to x plus, I think I said the wrong thing, 18 to x plus 22 and then 6 to x plus 2, that would be fine. It's just that I chose to compare the 18 and the 6 because that simplifies nicely. You could also, if you prefer, you could use similar triangles. And you can say 18 is to 24. This whole thing here would be 24. As x plus 22 is to this whole length, which would be 2x plus 24. So that will still work. It's just kind of a little clunkier, but any of those ways would work. Okay, in the second problem, it says, determine whether segment BC is parallel to segment DE and then justify your answer. So this time we weren't given that those segments are parallel. We want to know if they're parallel. Now, they're going to be parallel if the segments on the sides are proportional. So we're basically checking the side splitter theorem. If they're not proportional, then that means that the side splitter theorem doesn't work, which means they aren't parallel. So it gave you AD is 15, it gave you DB is 12, AE is 10, and EC is 8. So we're just checking, is 15 to 10, is that equal to 12 to 8? Or you could check 15 to 12 and see if that's equal to 10 to 8 or any similar, any equivalent proportion. So I'm just going to simplify the left side. Divided by 5 would make it 3 to 2. On the right side, if you divided by 4, it'd be 3 to 2, and that checks. So since those are proportional, that makes DE parallel to BC. So your answer on this one is yes. Okay, and then two more little questions here. On this one, notice that this is a 1 to 2 ratio. Same thing over here. This is a 1 to 2 ratio. So you could say 1 is to 2 as x is to 35. Now again, I'm using the whole entire side of the triangle because this triangle here is similar to the triangle here because we have angle-angle similarity. I did not do that x is to 1 as 35 is to 1. Okay, I'm not comparing the little pieces to whole sides of triangles. I'm comparing sides of triangles to sides of triangles. So that would mean that x has to be 17.5. Now, another way of doing that, which is probably simpler, if you notice that this thing's a midsegment, and again, we know that because these are midpoints of sides, and a midsegment is parallel to the base of the triangle. So if this is a midsegment, you can just use that a midsegment is 1/2 of the side to which is parallel. So just 35 divided by 2, or 1/2 of 35 would give you your 17.5. Either way would work. Okay, similar for this one down here. couple different ways you could set this up. You could say x is to x plus 12. Again, I'm using the side splitter theorem because those are parallel. So x is to x plus 12 as 11, and this down here would be 22, as 11 is to 22. Now again, I'm comparing the numbers to each other because I would like to be able to simplify. And so notice 11 over 22 makes it 1/2, which is nice. So x over x plus 12 equals 1/2. So 2x is x plus 12, and x equals 12. Other options. You could do the similar triangles, or you could set up the proportion by bouncing back and forth. You could do x is to 11 as x plus 12 is to 22, for example. Or you can use the similar triangles like we talked about up here. So using similar triangles, it would be x is to this whole side length, which is 2x plus 12, and then 11 to 33, which is this whole side of the big triangle. So again, that's using that the triangles are similar. So again, a little more cumbersome, but if you feel like you might get confused about when you have to use similar triangles, then similar triangles will always work. So that would go x is to 2x plus 12 as 11 is to 33, or again, any comparable proportion.